Hi, we're a team of 3 ECE students at the University at Albany, and for our senior project, we're working on designing a CubeSat. CubeSats are small satellites, approximately the size of a Rubik's Cube, that have been enabling enthusiasts, universities, and developing nations to get involved in space research over the last couple of decades. Not only are they cheaper to manufacture than typical full-scale satellites, they are cheaper to design and to launch due to their small size and relatively low complexity. According to NASA, previous Earth-orbiting satellites have proven that low-frequency radar technology has the ability to collect data on the composition of the Earth several meters below the surface. For example, NASA has been applying this work to help archaeologists identify areas of archaeological interest and has been used to map now buried rivers in the Sahara. Dr. Mustafa Aksoy, a professor at the University at Albany, is currently utilizing data collected from the Chinese satellites Chang'e 1 and 2 to identify areas of natural resources that can be exploited during future lunar missions. According to Dr. Aksoy, if a constellation of multiple CubeSats utilizing this technology were deployed around the Moon, many points of interest could be located, such as locations of important natural resources and stable locations for lunar bases. Our team is working on a CubeSat that can act as a proof of concept for this mission by implementing a low-frequency radiometer to do ground penetration scanning. While the CubeSat we design will be orbiting the Earth, if it proves successful, the exact same technology can be used on the Moon. Imagine a window during winter. When you put your hand against the glass, you can feel the cold seeping through. If you move your hand to the wall right next to it, there would be very little cold coming in from the outside. The sensors on the UAlbany 1 operate in a very similar manner to your hand, detecting the changes in temperature on and below the Earth's surface. These readings can enable scientists to determine the composition of the Earth below the surface and can be used to identify areas of interest. The UAlbany 1 is made up of 4 interconnecting parts. The central system is responsible for the basic operational functions of the UAlbany 1, including correcting the flight path and regulating power. The communications system is responsible for storing and relaying data to the ground base, which can then be processed by researchers. The scientific payload, or radiometer system, is responsible for the data collection and is the primary purpose of this CubeSat. The final part of the UAlbany 1 is the system responsible for the calibration of the radiometer, which is necessary to get usable data. Before launching, the UAlbany 1 must go through rigorous testing. This is to ensure that everything is working properly and that the CubeSat won't fall apart during the launch and deployment. Once everything is confirmed to be operating correctly, the UAlbany 1 will be taken on a shuttle to the International Space Station, where it will be launched into low Earth orbit. It will orbit for 1 year, being monitored by a team of students at the University at Albany. Work on the UAlbany 1 started in September of 2019 with the identification of the mission's goal. After the mission was defined, the team began designing a full simulation of the payload. Simulated lunar rock and ice emission data were provided by Dr. Aksoy, and this was used to validate the design before acquiring hardware. The simulation produced clear differences in the output data based on the input, which is what the team was aiming for. The team was able to secure funds and donations for the hardware to test the system, which will be available for the next team to do. In addition, the team has begun the process of identifying the antenna to be used for this system, laying the groundwork for the next team.